Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest video. This one's titled Mild for Now, Colder Pattern Ahead. And of course, we're sitting now on the 30th of December 2022, and the graphic here on the title slide of tonight's video showing a Times Square celebration. You can see a lot of the confetti there, multicolored confetti in Times Square from a previous New Year's Eve. Never been there myself, but I just can't imagine how packed it must be for such an event. But it'd be a really cool thing to see at some point in person. New York looking at for a milder and wetter New Year's Eve tomorrow night. But now I'm going to go right into tonight's video, and I want to talk about what we're looking at right now. All right, so like I mentioned in my previous video, I talked about the importance of this highly zonal. When I say zonal, I mean a configuration of the jet stream pretty much from west to east when I say highly zonal. And we have that. This is a forecast from the GFS version 16 for the Northeast Pacific. This forecast on the left, this graphic, is for next Friday, the 6th of January. And you really see what's going on here from Tokyo, Japan, right on across the Pacific Ocean. We have a very strong, in excess of 200 knot jet stream, and we have a west to east highly zonal jet stream. We do see a little bit of troughing off the U.S. West Coast. And then over here on the right, I'm showing the graphic for Monday, the 9th of January 2023, showing that configuration of the jet stream, still fairly highly zonal, but then you're starting to see some changes here downstream over the eastern North Pacific here, where you're starting to see more of a deeper troughing setting up here. And then that leads to higher heights downstream over the western portion of the United States. All right, so we could be looking at some potential changes ahead from a highly zonal west-east Pacific jet stream, which is just going to really help direct or guide storm systems into California with lots of heavy rain coming up. And by the way, I looked at this and I thought to myself, if you were a pilot flying a plane from, say, Tokyo right onto the west coast of the United States to California, you probably can get there fairly quickly utilizing the jet stream. It could conserve a lot of fuel also, by the way. But anyway, we're looking at a potential change to this specific jet stream over time. Again, 6 January on the left and then 9 January here on the right. We're starting to see more of a meridional pattern here towards the end of the model run. So this is something to watch. Rising or higher heights along the U.S. West Coast. Now, let's take a look at the stratospheric polar vortex forecast, and let's see how things change over time with this. This is the GFS forecast. If you look at the graphic here on the left, this is the forecast for today, for this afternoon, and what the vortex looks like. Now, we're looking at 10 hectopascal level. We're looking at the temperatures as well as the anomalies in degrees Celsius. So when you see purple coloring, it's very cold, below normal, colder than normal temperature anomalies, very cold air by the purple colorings. The maroon colorings is the coldest departures from normal. And then when you see the whiter or lighter brown and the orange coloring, that indicates above normal temperatures. So initially what we have is below normal temperatures, generally where we'd expect them to be, over the higher latitudes up towards the polar area for today, the 30th of December. A more circular shape to this outline of the temperature regime, the temperature departure regime. And then look what happens over time here, the forecast here on the right from the GFS. This is now on Sunday, the 8th of January, 2023, next Sunday. And look what's happening here. See how this area of green, these below normal temperatures in the stratosphere, and the purple, how this is becoming more elongated shaped. It's no longer symmetrical or circular. The GFS forecast showing that polar vortex in the stratosphere to become more elongated or stretched out. Moving ahead on the GFS stratospheric polar vortex forecast here on the left for 11 January 2023, and you're still seeing that elongated look. The stretched out look of the stratospheric polar vortex on the GFS latest model this evening, 18Z run. And then over here on the right is the forecast for Sunday, the 15th of January 2023. And look at the purple coloring here. See this purple coloring? Notice what's going on here. See this? Notice how it is dipping further. The stretched out look of the polar vortex is stretching all the way down to the eastern United States. This is looking at more like a colder pattern for the eastern U.S. by 15 January if this were to verify. Now let's move on to the GFS Ensemble forecasting system, stratospheric polar vortex forecast. So this is the GFS Ensemble showing a very similar pattern here to the circular shaped vortex. Coldest temperatures where they should be, Siberia as far as the North Pole area. And then over here on the right is the forecast for the stratospheric polar vortex. This is now for 7 January, next Saturday, the 7th of January 2023. Look at the stretched, how this appearance of this stretched out, elongated look of these colder than normal temperatures in the stratosphere. So a much more stretched out, elongated look by the 7th of January in accordance with the Jeffs model. We look at the Jeffs further into the future. This is the forecast for Saturday 00Z on 14 January 2023. And you see again more of a stretched look. See this? Look at this. Look at how stretched out this is. And we got warming basically over parts of Siberia, over parts of Northern Europe, over the top of this thing by these lighter brown colorings. So now we're 2 for 2, right? We look for, one of the things with models is, of course, we're looking for consistency. We want to see if all these models are basically lining up. Of course, the shorter the range, the better the probability, the higher probability of greater accuracy with the models as well. So right now, the GFS forecast showing an elongation of the stratospheric polar vortex by 8 January. That elongation still there on 11 January. And then we got a big chunk of colder air and that elongated look into the northeastern portion of the United States down to the mid-Atlantic. Jeffs showing a very similar situation, elongation by 7 January. This would be next Saturday. And then again, look at that elongation look from northwest to southeast by the 14th of January on the Jeffs. What about the European model? The European model, this is the forecast for tomorrow morning, New Year's Eve, showing that more of a circular pattern now when we're looking at European forecasts here, we're looking at 10 hectopascal temperature anomalies in degrees Celsius. Purple and blue, the purple and magenta colors indicating the greatest or coldest temperature departures from normal, and then this lighter brown coloring indicating the warmest temperature departures from normal. So tomorrow, the forecast from the European model at 10 hectopascals and the stratosphere temperature outlook showing very cold temperatures where it should be for this time of year, and the far northern latitudes, Arctic Ocean, North Pole area. And then here's the forecast for the European model on the right for the 8th of January. And notice what's happening again. See where this is? Elongation again. All the way down from eastern Canada to the eastern US. See that? And so just in review before I move on, look at the elongation of the vortex. Okay? Whether we're looking at the GFS, we see it here. And look at where the placement is from southeastern Canada into the United States. Southeastern Canada right on down into the southeastern or the northeastern portion of the U.S. down to the mid-Atlantic. And then continued more of a stretched look there across the upper Midwest and eastern U.S. And then the European model showing a similar outcome. So we're basically seeing all three models by 7 and 8 January showing a stretched out look to the stratospheric polar vortex. Whether we're looking at GFS operational, whether we're looking at the GFS ensemble, whether we're looking at the European model. They're all showing it, and trends are our friends, okay? So just looking out at time here, it's looking really interesting as far as the behavior of the stratospheric polar vortex. So what happens when we get an elongated stratospheric polar vortex? How does this impact our polar jet stream? The white dashed line here with the arrowheads indicates the overall position of the jet stream axis, when we have an elongated or stretched out polar vortex. And look what happens here. We get more of a troughing situation or upper air pattern from the Midwest right on down to the mid-Atlantic, okay? The eastern U.S. is basically seeing an upper air trough. And with the upper air trough, you typically get colder temperatures as well as, in some cases, more unsettled weather. Okay, so you see this dip in the jet stream, the polar jet stream. We got ridging or rising heights, upper level ridging over the western U.S. when we have a typical elongation of the stratospheric polar vortex. So I just wanted to show you the importance of it in relation to the jet stream. What about elongation and temperature anomalies? Now I'm going to go back 3 months. I'm going to start with this December on this slide. then I'm going to work my way back to November, then I'm going to work my way back to October. And I'm going to show you what the vortex look like, okay? Here on the left of each of these slides, I'm going to show you the northern hemisphere temperature pattern up in the stratosphere, and the white solid lines indicate these height contours, okay? Whenever they're stretched or elongated, the white lines, these solid white lines like this, that indicates a stretched or elongated polar vortex. All right, so back on the, this would be the 22nd of December here on the left of the polar vortex. By the way, the blue coloring indicates colder than normal temps, or colder temperatures in general in the stratosphere, and the yellow coloring and the green coloring indicates milder temperatures in the stratosphere. So the vortex, what it looked like on the 22nd of December prior to this extremely cold air mass that moved in, look how stretched out it is. See these white solid lines, how they're more elongated? It's almost like taking a rubber band and just stretching it out between your two index fingers. Okay? And then on the right here shows the temperature anomalies across the United States when this vortex is elongated or stretched out like this. Look what happened. Look how extremely cold the temperatures were. Now, why did we get so frigid around 23, 24, 25 December of 2022? It was more than just a stretched out elongated vortex in the stratosphere. There's also a couple of other teleconnections that played big into that. And one of the biggest ones was a strongly negative Eastern Pacific oscillation. Just as an example, in a negative NAO, a negative AO, they all kind of teamed up with this stretched polar vortex. But I just wanted to show you, if we just isolate the vortex alone and the resultant temperature departures from normal, whether we're talking max temp anomalies here or minimum temperature anomalies, you can see the purple all over the United States, right? Let's move back now to November, late November. This was the 20th of November. Look at what's going on here on the left with the polar vortex in the stratosphere. See the white solid lines again, these height contours? Look how elongated or stretched out this look is, okay? Again, this is a case of a stretched out or elongated stratospheric polar vortex. See that? The shape? And then look at the temperature departures from normal with this case. Okay, now this case, in addition to that elongated stratospheric polar vortex, we also had an extremely positive Pacific North American pattern at PNA with a anomalous upper level ridge or blocking up into Alaska, that particular area of the world, which also helped constructively interfere with this elongation of the polar vortex. So again, we had another teleconnection, the strongly positive PNA team up with this elongation of the vortex at the right time to give very cold temperature anomalies on 20 November. Look what happened here. Look at the purple coloring again across the United States. Now let's look at October. Now in October, your stratospheric polar vortex isn't nearly as strong, all right, because right now the polar areas are just starting to cool off and your mid-latitudes are still fairly warm. So you don't have a very strong temperature, a latitudinal temperature gradient in October. So therefore, the stratospheric polar vortex is weaker. So that's why you don't see the white solid lines here, these height contours, as closely packed as, say, that you would see here in December. See how much closely more packed these height contours are, these white lines, compared to October? Just wanted to point that out. So we still see a little bit of a stretching pattern, though, in these white solid lines, don't we? So we have an elongation of the polar vortex, which it was a weaker situation, of course, in late October. But then look at the temperature anomalies. Max temperature anomalies, degrees Fahrenheit, on the 19th of October, showing good 8 to 12 degrees Fahrenheit below normal temperature departures from the Midwest, the East Coast. And then the minimum overnight low temperature anomalies were also very cold. Right, so I just want to give you an example of stratospheric polar vortex elongation or stretching and resultant temperature anomalies. We've had 3 cases this year alone. I did not do the research tonight necessarily and go back further than that, but I just wanted to show you if, look at potential relationships there. December, which we just got over the very frigid temperatures, late November, and late October. One other thing I wanted to point out, and I mentioned this already, sometimes the atmosphere gets into these cycles or patterns where it just repeats itself over given time intervals. All right. So you notice October, right? October, we had colder than normal temperatures across the eastern U.S. You notice November. Now, this was October 19th. This was November 20th, almost 30 days later. Very much colder than normal across the east. This was October 19th, below normal in the east. So you see the pattern here? Every 30 days or so since October 19th, we have seen an anomalous period of colder than normal temps across the eastern U.S. So October 19th, let me go through it again, November 20th, and then December 23rd. So, you never know. I'm always looking at those clues from the atmosphere. Sometimes, again, the atmosphere gets stuck in a certain cyclical pattern. And so I just think it's really interesting to look at. So we'll have to see how things play out in late January around this time period, say around the 20th of January. If we see this kind of temperature anomaly in the east, it'll be very interesting to see. Now, let's talk about the La Nina. It continues to weaken. In fact, I just took a look this evening at the latest CPC Climate Prediction Center, the NOAA CPC official probabilistic ENSO forecasts. All right, looking at the bar graph here on the left, blue bar, the blue vertical bar indicates La Nina forecast. Here are the probabilities, by the way, on the vertical y-axis over here on the far left. All right, so for December, January, and February, we're looking at about a 76% chance of La Nina and only about a 22%. Well, no, that'd be about 24% chance of ENSO neutral. The gray bar is ENSO neutral, by the way. Watch what happens over time with La Nina probability and how it goes down. From December, January, February, look at the blue bar now, and January, February, March. These are the months on the bottom of the x-axis, horizontal axis. So January, February, March, the blue bar is the same height as the gray bar, sitting at about a 50% probability of an La Nina or a 50% probability of ENSO neutral conditions in the months of January, February, and March. I put it right down here in plain writing for everybody to see. So there's a 50-50 probability of La Nina or ENSO neutral conditions between January and March. In other words, La Nina is weakening. This is the latest data from CPC. We do have a 71% chance of ENSO neutral conditions between February and April. That's huge. That's huge. If you look at the model predictions here from the IRI, the International Research Institute for Climate and Society, this was updated on the 19th of December, showing that general upward trend of these forecast models, these climate models, going from a departure of around 1 degree Celsius below normal in Nino 3.4 region, working their way in the forecast closer to minus 0.5 degree Celsius temperature departure in that Nino 3.4 region by February, March, and April. All right, so the upward trend is there, and this is very interesting with a weakening La Nina. Now, I wanted to show you La Nina winter snowfall. This is average snowfall patterns for all La Nina years. Now, these are departures from average seasonal snowfall. So these are departures from normal, okay? All right, for all La Nina years, anything in the lighter brown shading, these brown colorings, that indicates below normal snowfall. And you can see that clearly from the Ohio Valley right to the Mid-Atlantic, specifically Virginia up to DC, up to eastern Pennsylvania. We have below normal snowfall during all La Nina years. You have above normal snowfall across the Pacific Northwest, across the upper Midwest, including Minnesota and Wisconsin, and then also above normal snowfall in La Nina winters across parts of New York State, northern Vermont, New Hampshire, and Maine. Okay? Now look over here on the right. This is average snowfall departures from normal for weak La Nina years. Now, we are sitting in a weak La Nina year at this point. It had gone to moderate level La Nina strength, but now it's back down to a weak La Nina. And during weak La Nina winters, the white coloring here with no indication of no brown or blue, just white, that indicates near normal seasonal snowfall, okay? So a lot of the East Coast gets near normal. You get above normal up towards Massachusetts, Connecticut, Rhode Island, Vermont, New Hampshire, and Maine during a weak La Nina year. You also get above normal snowfall across the upper Midwest, Iowa, Minnesota, Wisconsin, parts of western Illinois, the Dakotas, eastern Nebraska, and you still see that above normal snowfall across the Pacific Northwest area. You do see in a weak La Nina winter more below normal snowfalls across New Mexico as well as the higher elevations of Arizona, eastern Colorado. Now, what happens to snowfall how many inches of snow do we typically see? Now, I'm not looking at departures from normal here now, but I wanted to show you a schematic of an ENSO neutral snowfall winter. All right. Now, since we could be potentially transitioning from La Nina to a ENSO neutral situation, specifically in the month of February, late winter, I want to take a look at the neutral year mean or average of snowfall in inches. Now, this was from 1948 to 2006. It's a little bit outdated, but I just wanted to show you the general patterns. It covers a significant chunk of time, over 50 years. And in general, we see 1 to 5 inch snowfall generally across the eastern Carolinas, southeastern Virginia, parts of South Carolina, right? And then as you go further north, of course, you see the purple coloring that indicates greater amounts of snowfall, right? So I just want to kind of give you a picture of what snowfall in inches would look like in an ENSO neutral situation. Now let's move on to the MJO forecast, okay? And I'm showing these specific elements, or these specific considerations to tonight's video and the upcoming forecast because I feel these are the most important. We look at the Madden-Julian oscillation or MJO forecast. This has to do with where that convection or upward vertical rising air motion is occurring across the globe in the tropical areas of the globe. All right, so let's take a look at the forecast here. So the graphic here on the left shows the GFS ensemble forecasting system. The thicker green line indicates the average of all the different ensemble model members. Now you see all the different model members are shown in the yellow lines. These are the other model member forecasts. The thinner green line indicates week 2 forecast out to January the 13th, 2023. So you see where we're starting right here. We're in a phase 6 right now, which is a very mild phase that generally results in milder temps in the eastern U.S. in a phase 6. But notice it goes to week phase 7, and then that green line, the average ensemble mean, goes into the null phase, the small inner circle, minimal impact by the MJO to our pattern, working its way back out to a weaker phase 8. Now some of these other model members are showing a stronger, these yellow lines are further, greater in magnitude or further from this small inner circle out into phase 8, and then even this one out here goes all the way to phase 1, where the convection is concentrated across the western hemisphere in Africa. Right? Look at the European forecast here in the middle. This is where we're starting on the 29th of December in phase 6, matching up quite well with the Jeffs, moving our way towards phase 7. That's still very mild across the eastern U.S. By the 1st of January, we're still in phase 7, but then this red line moves basically along the edge of the null phase right back into phase 8, European phase 8. Okay? And then over here on the right is the Jeffs V12. This is the extended Jeffs V12 out to the 29th of January. So we're starting here on the 28th of December. We're in a weak phase 6, moving into a weak phase 7, and then working our way into a null phase. Okay. And then finally, the CFS MJO forecast, courtesy of Kyle McRitchie, showing a general null phase. See the dates associated with each of these dots, the different runs, showing that we're pretty much situated in the small inner circle, which if the CFS were right, that would mean we wouldn't have much impact from the MJO as far as our pattern goes in the United States. This one goes all the way out to the end of January, the 29th of January. All right, now look at this right over here. The temperature composites on the right for the months of January, February, March. The orange coloring indicates above normal temperature departures. The blue coloring below normal temperature departures. So if you want colder temps in the east, you want phases 8, phases 1, phases 2, and phases 3. Okay, that'll give you colder than normal temps in the eastern U.S. If you like mild temperatures like we're seeing right now across the east, you want phases 4 through 7. And in fact, right now we're in phase 6. Look at this. Look how it's matching up. We're situated in phase 6 right now. Okay, phase 6. And look at what phase 6 looks like. Look how much above normal the temperatures are from the Midwest to the East Coast up to New England, down to Florida. Florida, you're 80 degrees again. Like that really frigid air that you had last week can't even remember it now, can you? You're back outside and it feels like summer again, right? And then the importance of going to potentially phase 8, look at phase 8. That's where you get your troughing in the eastern U.S. with phase 8 and the colder temperatures. So that's the importance of the forecast, the MJO, moving forward. If it goes into phase 8, that could definitely result in a change to colder temperatures in the east. Now let's look at the Teleconnection's latest forecast. I'm looking Generally, at the ensemble runs for the Teleconnections forecast, I just trust them more. They seem to have a little bit more stability. So I'm just going to look at the European ensemble in tonight's video. I really like this particular ensemble as far as past performance. All right, green dash line indicates your ensemble average of all the 50 perturbed members of this particular ensemble system. So you notice here, this is the AO, Arctic Oscillation Forecast, upper left. The green line showing us in a negative phase of the AO, working our way to neutral conditions, 7, 8, 9 January, then dipping back negative again from 9 to 14 January. That's the latest EPS AO, or Arctic Oscillation Forecast. Looking over here on the North Atlantic Oscillation Forecast, this thing, NAO, was extremely negative for a while in December, but now it's gone positive on us. See, as we go into early January, New Year's Eve, New Year's Day, we got a positive NAO now. All right, and then we go to neutral conditions from the 3rd right to the 5th of January, and then we're going positive again, slightly positive, right on to about the 10th of January, and then we go slightly negative 10 to 14 January on the NAO. Look at the bottom left here. This is the European EPS forecast for the Eastern Pacific Oscillation, EPO. We're positive to start. We go closer to neutral around the 4th to the 5th of January of the EPO. Then we go back positive again. Slightly positive, not strongly positive. There's a difference. And then bottom right here, European Ensemble Protection System PNA forecast, showing a fairly neutral PNA right on through the 9th of January, then slightly positive on 9 to 13 January. So if you look at the overall picture of the teleconnections here, we don't see anything that's really abnormally positive or abnormally negative. All right, we see most of these teleconnections, just kind of these green lines here, the solid green line, in all of these cases, generally either slightly positive, maybe going slightly negative for a little bit of time, but in general, we're closer to the 0 line here. This is your neutral line, okay? Here are my final thoughts on tonight's video. Mild air is going to remain in place across the eastern U.S. right on through Wednesday, next Wednesday, the 4th of January. Why? We have a strongly zonal Pacific jet stream moving west to east. We have strong stratospheric polar vortex at the present time. And we have a warmer MJO phase 6, which we talked about here, right? We talked about whether we're looking at the Jeffs, whether we're looking at the European, whether we're looking at the Jeffs V12. All of them showing us where we're at right now. We're in a warmer MJO phase 6, which correlates with something like this, above normal temperature departures in the east, right? So we will stay warm and mild for quite some time still. Colder air will move in behind a cold frontal passage. Also, we'll get a little bit of rain in the mid-Atlantic Wednesday, the 4th of January, into Thursday, the 5th of January next week. But then there will be some colder air that moves in on Thursday, the 5th of January, and Friday, the 6th of January. But I expect it to be a transient shot of colder air, and that will be interspersed with another milder period. So cooler shots of air interspersed with milder temperature periods right on through mid-January. It doesn't look like anything significant is going to change in this pattern, most likely through the 15th of January. We will see a little bit of dips in that jet stream. We'll see some upper air troughs dig in, but not so deep into the eastern U.S. The Pacific jet stream zonal flow, I showed you this at the beginning of the video tonight. It changes around 9 January from very highly zonal to potential more meridional there, the eastern Pacific, with rising heights downstream over the western U.S. You'll have a trough offshore that kind of retrogresses back to the west over the eastern Pacific, and then you get rising heights downstream from that trough over the western U.S. Now that is going to result in that slightly positive PNA pattern. Not significantly strong, just slightly strong. This one is a big one to me. Okay, the stratospheric polar vortex, and I've been watching this for 3 days, and I know everybody, and I've been posting some images on Twitter, and everybody, of course, the further out in time you go, the less reliable the model. We all know this. But really, when I show more extended forecasts for the stratospheric polar vortex, my main point here is to look at the trends. Trends, and see if it's changed. And I've looked at this over the last 3 days, and really there's not been much change to this. Stratospheric polar vortex becomes stretched or elongated, generally starting from the 7th of January, so towards the end of this upcoming week. to the 15th of January, we have a stretch or elongated appearance of the vortex. This is going to lead to a higher probability of colder temps across the eastern U.S. Now, I said higher probability, right? So that doesn't definitely mean it's a slam dunk for the eastern U.S. to get colder temperatures with this elongated vortex. It's just higher probability than normal, okay? There's been cases where the vortex has elongated and the coldest air was over western Canada, right on down to the Pacific Northwest. But it usually favors colder temps across the eastern U.S., so that's what I'm looking at. Now, there are hints of colder air across the eastern U.S. after the mid-month period. That's what I'm really interested to see how the models handle the longer range with this stratospheric polar vortex becoming elongated. Teleconnections right now, in my opinion, just are not overwhelming. They're not overwhelming as far as support of anomalously cold temperature departures. They're not strongly positive. They're not strongly negative. And, I could also say teleconnections are not overwhelming in support of anomalously warm temperature departures. We do have a lot of things coming together and constructively interfering with each other and resulting in some mild temps across the east right now. There is a lack of high latitude blocking. That is the one thing I just don't see in today's ensembles. I decided to take a different approach to tonight's video, if you noticed. I'm not really showing the ensemble forecast projections at 500 millibars like I normally do. But I did take a look at those and I've been paying close attention to those. And there's really not much of a high latitude blocking on the North Atlantic or the North Pacific side. And so I just don't see like bitterly cold air trajectories coming in, cross-polar flow situations like we saw around the Christmas holiday from Siberia right into I don't see it through middle of January, that kind of cold air, bitterly cold air trajectory. Subject to change, but right now there's not much in the way of high latitude blocks going on. The MJO, very important here. Now, if this were to move into phase 8, a colder phase for temperatures in the eastern U.S., in the middle of January, this would definitely favor a colder pattern. This needs to be watched. I've seen this happen before with the MJO forecast where it looks like it's heading towards phase 8 and then miraculously it just kind of spins back in, rotates back into the null phase, the small inner circle on those RMM diagrams. So, we'll see what happens here over time. La Nina is weakening, and that's going to continue to occur from January right to March. That can actually favor a less La Nina type pattern towards the late winter, specifically late January to mid-February. That could potentially favor stronger cold air pushes into the U.S. Where specifically in the U.S. remains to be determined, but something to keep an eye on with La Nina weakening. All the climate models are indicating this. The sooner it weakens, the greater the probability we could see some wintry weather across the eastern U.S., I do believe. And then, of course, tying in with that, snow chances climatologically peak from mid-January to mid-February, specifically for the mid-Atlantic states. You go a little bit further north towards New England, you have snow chances, well into March. But latitude is a really good friend in the mid-Atlantic states, really from mid-January to mid-February, where we typically see our coldest water temperatures offshore of the winter during that time period. And we usually see just that favored period, storm trajectories, storm tracks, stuff like that. All right, that wraps it up tonight. Hope you enjoyed the video. Hope you learn stuff every time you watch this my videos. This vortex looks interesting, this polar vortex. And again, we'll have to see what happens over time. These models are subject to change. But generally what we're looking at is a mild New Year's Eve. Tomorrow for sure, a very mild New Year's Eve and a very mild beginning to the new year in early January for many locations in the east. I have watched the models recently, and I tell you, it does look like the models have trended a bit colder over the past 24 hours for the eastern U.S., specifically New England and the Mid-Atlantic for the time period late next week, the 6th to the 7th of January. It has trended a bit colder over the past 24 hours. So, looking at the forecast overall, the model runs, it doesn't look like we're going to just see some anomalously huge southeast ridge at this point in time developing and just unseasonable warmth in January. There is going to be some cooler intrusions of air too. And I'll be intrigued to see, again, what these factors do. How this zonal Pacific jet stream changes configuration, What happens with this polar vortex? I think this is a huge key to getting colder air in the eastern U.S. If for some reason this were to change and the polar vortex were to remain exceptionally strong, that really is going to limit the atmospheric circulation pattern to deliver colder air in the eastern U.S. But right now things are looking really good and it's elongated. We've seen this. I showed you December, late November, late October. We've seen this elongation take shape in the latter parts of October, November, and December. And you get colder temperatures across the eastern U.S. in all these cases. The La Nina, again, key as far as weakening of it, kind of showed you the differences in the snowfall departures and actual amounts. And this MJO forecast is big too, in my opinion. All right, that wraps things up. I wish everybody a happy new year. Take care and God bless each and every one of you. Thanks for subscribing to the channel. And until next time, everybody, take care, God bless, and Happy New Year.